Okay, good afternoon, everyone. Am I audible to you?
Yes, sir.
Yes, sir.
Yes. Yes, thank you. So yesterday we were thinking or discussing about the difference between microprocessor and controller, and major differences were covered yesterday itself. I think we have covered six different points to differentiate the microprocessor and microcontroller. So please note down point number seven. We said that in a microprocessor based system, it requires the heavy hardware or extra hardware is required. So the point is large interfacing hardware required. For microprocessor, large interfacing hardware is required because we require to connect separate memory, separate I/O devices, interfacing devices. So obviously it increases the hardware. We require separate decoders, we require separate multiplexers, and so on. But that is not the case with the microcontroller. Of course, with the help of microcontroller, we require some sort of circuitry, but all the components are inbuilt inside. Memory, interfacing devices like I/O devices are present inside. So we require somewhat lesser hardware as compared to microprocessor based system. So that is point number seven. Then point number eight. Normally, where we use the processor and controller, the microprocessor is used where we have to handle a large industrial applications. I mean, where multiple peripheral devices are required to be controlled. Then we go for the microprocessor based system. The best example is our computer or laptop is the highest, I mean, the best example of microprocessor. Of course, the frequency has been increased now. The clock frequency is increased, so it is not called as a microcontroller, microprocessor. But then it is used to handle large industrial applications. But that is not the case with the microcontroller. The point is microcontrollers are used for small dedicated applications, like in a bike, in a Pulsar there is a DTSI system, digital twin ignition system. There we use microcontroller. For washing machine applications, we use microcontroller. So for small applications, we go for microcontroller. Many of the students are doing the projects, last year projects. They are based on Arduino kit, or some of them are based on PIC 18 controller, peripheral interfacing device controller, PIC microcontroller. So microcontrollers are used for small dedicated purpose. So that is point number eight. Application wise, please write down the applications. For microprocessor, the applications are desktop, laptop, are the applications of microprocessor, wherein in the column of microcontroller, you can write refrigeration, washing machine, like this. And again, the last point in a microprocessor column, please note down example of devices. 8085, which is developed by Intel Corporation. The first was 4004, and then 8008, 8080, 8085, 8086. I said. So those are nothing but all the microprocessors developed by Intel. Similarly, some microcontrollers are developed by microchip. Those are like a PIC. So in a column of first microprocessor, you can write 8085, 8086, example wise, and in a microcontroller, you can write PIC, PIC 12, PIC 16, PIC 18, and 8051. 8051 is developed by Intel, and PICs are developed by microchip. So that is, I mean, we have covered 9, 10 points regarding microprocessor and microcontroller, and that will give you 5 marks. Okay, so the next point. Now we are starting with chapter number 2. In chapter number 2, okay, in chapter number 2, we will start understanding the device which is given us for the study. That device is known as PIC18F microcontroller. So this is here, PIC18 microcontroller. Now in this PIC18 microcontroller, there are number of different devices like 4520, 4220 and so on. So what do you mean by PIC? The PIC is known as a peripheral interfacing device. So right, peripheral interfacing controller. In short, it is called as PIC controller. And then the variants are there. For your study, they have given us PIC18. So peripheral interfacing controller is not a processor. Now we have to shift entirely to microcontroller. That is peripheral interfacing microcontroller and PIC18. Before I move towards the internal architecture, what are the different components which are present in a PIC18 controller? First of all, we know one thing that single IC, the IC which is known as microcontroller, it is having a memory, and the memory is of two types. One memory is called as program memory, other memory is called as a data memory. So at this point of time, we can say a program memory where we can store a program to add, subtract, logically or logically and this one. So this is what called as a set of instruction called as program. So that program should be stored in one place or one memory. That memory is called as program memory. So this has two memory. First memory is program memory. And then it requires, this is actually a ROM memory, EPROM memory, but ROM memory, you can say ROM memory. Apart from that, there is one more memory slot, and that memory is called as random access memory, or in other words, it is called as data memory. Because my program requires always, because when we write a program, that program requires some data. So if I have to go for mathematical operations or if I want to go for the logical operations, okay, instructions are there. Instructions are called as program. But then on which we have to perform the mathematical operation, that is called as data. So data must be kept in one more memory. That memory is called as data memory. So it consists of one more memory known as data memory. In short, this is known as PM and this is known as TM. Can you able to see that? I hope. Yeah. Now what it consists of? First of all, let us try and understand the structure of program memory and structure of data memory. Sometimes this is a separate question to be asked for even 10 marks. But here we will brief the contents about the memory of a PIC18 microcontroller. Now see, now this program memory is nothing but a single chip, that is IC, and that IC consists of number of registers. So for example, this is a memory IC and it consists of number of registers 1, 2, 3, 4, 5, 6, 7. Likewise, number of registers are present. So this is 1, this is second, this is third, fourth. Likewise, suppose this is the last register. Now, what is the size of every register? Every register is of 8 bit. So we can store 8 bit content, 8 bit instruction in that slot. And 8 bit means what? It is a flip flop 1, 2, 3. So likewise, 8 different flip flops are joined together. that is called as one register. One register is of 8 bit. So this is a 8-bit register. This one is 8-bit register. So like the last one is also a 8-bit register. Fine. So now this, how many different registers are present? Different registers are present are equal to 2 megabyte. I mean almost 10 lakh. So 20 lakh registers are clubbed together in single IC. So that is nearly 2 megabyte. Now when I say 2 megabyte means what? Every register is of 8 bit and such a we have 2 mega registers. So I can write the memory size as 2m into 8. Why it is 8? Because every space is of 8 bits. So there I can store a 8 bit instruction. I can able to store this much of instructions 2 megabyte. Not exactly because every instruction requires at least 2 bytes or 4 bytes, but at least as we go ahead. But how many registers are there? We have 2 megabyte registers present in this program memory. And this memory is random, so not random, read-only memory. More specifically, it is EPROM, a programmable read-only memory. Okay, now you may be remembering what I said in the first lecture. In the first lectures, we said that if I want to communicate with one of the location, we have to offer a specific address to that location. Fine. So the microprocessor or controller who wants to store the program in a program memory or who wants to retrieve the program from program memory, that time it has to communicate with each and every register it is present here. Then to communicate with one register at one time, because the biggest not difficulty, it is the limitation. The biggest limitation is what? The microcontroller communicates with only one location at one time. So when the reading writing is going on with register number 1, it is not possible for others. Otherwise, when reading writing, loading the content or retrieving the contents are doing with the last one, it is not happens with any of the register. So I mean to say that one communication at one time, and for that the specific address must be given. Fine. The way I said, when the courier boy has to deliver the package to a respective particular house, he must have that address. Otherwise, the data will go in other house. So the address must be given, and address of every house must be unique. Similarly, the address of this must be unique. Fine. Now, what to do for the address? For address, we require a bunch of line called as address bus. So this is a single line. This will give me two addresses. The first address is 0, second address is 1. So if the single line is there, we have two addresses. Similarly, if we have two lines, we may get 4 addresses. So if we have 2 lines, we will get 4 addresses. कसे काय बरं? 0 0 0 1 1 0 1 1. Apart from this, any other combination is not possible. Similarly, if we have 3 different lines, we will get 8 different addresses. The first address will be 0 0 0, second will be 0 0 1, third will be 0 1 0. Likewise, the last address will be 1 1 1. Apart from these combinations, no other combination is possible. So, if we have 3 lines, we will get 8 different addresses. Now, how we understood this? This will be understood by number of lines and based on the equation. Equation is 2 raised to n. N is what? Number of lines. Will be equal to number of locations which we want to assign the addresses. So see, we have locations equal to 2 megabyte. So if the locations are 2 megabyte, what is the value of n? We have to find out value of n, and value of n is nothing but number of lines which are there in an address bus. So when we solve this equation, we realize that number of lines are 21. One line, two addresses, two line, three addresses, three line, sorry, four addresses, three line, eight addresses, four line, 16 addresses, 16 number of lines, 64,536 addresses. Similarly, if we have 21 address lines, like a bunch of line 21, that time we can assign different 2 megabytes approximately. Exact value we can find out from the calci. Approximately 2 megabyte locations can be identified, and so that this memory is accessed with the help of address bus. That address bus is here. It's just for understanding. So this is the address, memory address, and the address bus required is of 21 bit, and the controller will decide the address. So this is known as address bus. It consists of how many lines? It consists of 21 lines. 1, 2, 3, 4, 5, 6, 7, 8, and this one. So obviously the first line is named as A0, the last line is named as A20. फर्स्ट लाईन आहे ना, ही पहिली लाईन, ही आहे ना पहिली लाईन ऍड्रेस बस मधली, त्याचं नाव काय बरं? त्याचं नाव आहे A0. सेकंड लाईन A1, A2, A3 असं करता करता लास्ट लाईन जी आहे ती आहे A20. सो वी रिक्वायर 21 बस ऍड्रेस बस टू कम्युनिकेट विथ द मेमरी. Then I can show it, but you can understand number of lines are there. Now let me put some more, information in this address bus and the addresses of location. आता बघा, माझ्याकडे कुठे आहेत 21 लाईन, आणि विथ द हेल्प ऑफ दिस 21 लाईन I must assign a unique address. Unique address which should not be transferable to other location. So this must be having unique address. This must be having unique address. This must be having unique addresses must be there. What are the contents present inside? That we don't have to bother about it. That we'll see when we write a program. Contents we don't have to bother about. We must find out what is the address of every location till we get to the last one. बघूया आपण. Yeah, the address of this register is all the lines A0 to A20. All lines must be 0. So, let me show it here and understand. The first line is A0, A1, A2, A3. Similarly, the last line will be A20. जर का या सगळ्या lines, all the lines are made 0 by the controller, means what? We are communicating with the first register. बघा, जर का सगळ्या lines, they should be here, A20. If all the lines are 0, this is the address given to the first location. If all address lines are 0, means what? We are presently communicating with very first address of memory, that is this one. If I want to communicate with the next location, The address must be unique and different than this. The address of second must be unique and different than this. The address will be A1 or A0 line should be 1, other lines must be 0. Now this is a unique address given to a second location. Similarly, if we have to communicate with the third memory register, then we have to assign a unique address to that location. What should we do? It is like 1 0. I mean A1 should be 1 and A0 should be 0. All the other lines are 0. Now will you please tell me? Will you please tell me what is the address of next register, fourth register as per this convention? What is the address of next register as per this logic? Yes, I was asking about if I want to communicate with very next register. Yes, Dikshit Pritesh. Very good. So, all these are 0, except the last two will be 1, 1. On a similar line, let me ask you, in this way, what will be the address of a very last register? This is after 2 megabyte locations. What will be the address of last one? What will be the address of the last one? Last, शेवटचं, Tejas. Last one. Third, fourth away. In between that, we have multiple registers. Now, last one. This one. Yes. All address lines must be 1. So this is, I mean, starting from left side actually. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. If you draw an entire map of this one, you will see that none of the address will be repeated. Unique address must be assigned to every register. And that has to happen. Because apart from this combination, if we are starting from all 0, and if we are go on changing a single bit every time, and we are reaching to the last 1111, definitely we have almost 2 megabyte different combinations, and that combinations are called as addresses. To be specific, the addresses are equal to how many? 1, 2, 3, 4, 5, 6 equal to, we have 2097152 different addresses. Means what? This is approximately 2 megabyte. एक byte अशा अनेक 2 mega, approximately 2 megabytes. So we say that the size of this memory is, to be exact, it is 20 lakh 97,152 different locations are there, and for which we require a bunch of line. This bunch of line is here A0 to A1. In that way, we assign the addresses to each and every location of memory. त्या मेमरीमध्ये काय आहे त्याची काळजी आता नको. How to store the content in the memory, that part we'll see afterwards. But how to communicate, how to access that memory location is done by address bus. Okay, no need to write like right now. Keep it as it is. Just draw this one. This is just for example. So now I have to write the very first address. If somebody asks me what is the first address, what is the address of first register, I will have to write 21 zeros. And if I want to write the address of last register, I will have to write 21 ones. And that is a very lengthy address, no? I just want to curtail the address and try to specify in a smaller digits. So why not? I should convert it into the hex number. If I consider this as a binary number, to curtail it or short it down, I will convert that into hex number. And this is the starting address and this is the end address. हा हे starting address binary, हा हे end address binary. So length जास्त असल्यामुळे I want to curtail down the length of address. So I convert this into a hexadecimal number. बघा. Binary 0000 म्हणजे काय hex मध्ये that is 0h. This is binary. If I plug it into hex, I'll get 0. This is binary, hex 0. This is binary, hex 0. This is binary, I get hex as a 0. Of course, now this is only a single digit. All other nibbles, if I convert it, I will get hex number, hexadecimal number 00000. This is a single digit, perhaps 3 digits are absent from binary, but still I'm going to get 0. So my starting address, this is starting address. Starting address of the map is given by 000000h. Hexadecimal. म्हणजेच काय 21 zeros in a binary. One more time. What is the last address? The last address is all 21 1. Length जास्त आहे ना address ची. We'll convert it into the hexadecimal. 1111 म्हणजे काय hex मध्ये f. This is f. माहिती आहे ना 15. 1 plus 2, 2 plus 4, 4 plus 8, 15. 15 म्हणजे काय बघा 10 म्हणजे a, 10a, 11 म्हणजे b, c, d, e and f. F is what? 15. So 1111 means f. 1111 f. This is again 11 f. This is 11, that is f, and this is a single, means 0001. If I convert this 0001 to hex number, I'm going to get 1. So this is 1. So this is the last address of the map. So this is last address. From binary 21 0 to binary 21 1, we have 2 megabyte different locations. In other words, we can say in a hex number starting from 00000h to 1ffff, we will have almost 2 megabyte different locations. Means what? Those many of addresses can be assigned to register. I just want to note it down here. Starting address and the last address. The starting address is 00000h. and last address is 1FFFFH. This H is called hexadecimal number. So I'm writing hex. बरं इथपर्यंत काही डिफिकल्टी आहे?
No, sir.
ओके, अदर्स प्लीज रिप्लाय. काही शंका असेल तर प्लीज विचारा मला. Others please reply. But definitely, I'm not going to tell you each and everything at this point. Slowly, I'm going to elaborate because telling everything will mess up the concept. So slowly, I'm going to add some more and more features, more and more points, and from there, after 4 or 5 lectures, you will be getting a clear idea about the device which we are going to study, and then based on that, you can write the answers. That is up to you. But understanding these concepts are very important. It can be asked for 10 marks. 5 marks for program memory and 5 marks for data memory. Okay, this paper, I mean, if I want to discuss about the paper, it is 80% of theory and 20% of program. Of course, you can show your interest in the programming, that will help you in a B also. So that is different thing, but as far as if we consider about the paper examination, it is of 80% theory and 20% program. So the address bus structure and everything we have mentioned here. But at the same time, again I go back to the first lecture. I said that for communication with, the processor wants to communicate with the memory, with the input devices, with the output device. And to communicate with this, it requires 3 buses. One of them is address bus, second bus is data bus, and third bus is control bus. Address bus to define the address to which we want to communicate at that point of time. I repeat, address bus to define a location or to identify the location to which we want to communicate at that point of time. Data bus. Data bus is used to carry some data from controller to memory or memory to controller. So here we have to show a data bus. Data bus is connected here. Even though I showed it as a 8-bit register, but data bus available to transfer the data from controller to memory and memory to controller. This is a large size, that is 16-bit data bus. So this is a data bus. It's a bunch of line. 1, 2, 3, 4, 5, 6. So 16 different lines are connected, and that bunch of line is called as a data bus. So obviously, the first line is called as D for data. D0, D1, D2, D3, D4. The last line is D15. So the first line is starting with D0, D1, D2, D3, D4. The last line is D15. In that way, we have a 16-bit data bus. Now, will you please tell me, address bus is one directional. This is one directional or bidirectional?
Bidirectional.
Bidirectional, because a data has to flow from controller to memory and memory to controller. So this is obviously a bidirectional data bus. So in short, this is known as 21-bit address bus, or this is known as 16-bit data bus. Now this is what the information about the program memory. Address bus है 21 bits, data bus है 16 bit. Okay, the similar line will go with the data. It's a function का है. It has to store the program, and whenever required, we can retrieve and execute the program. So it is used to store a program. State of instruction is called as program. But I hope difficulty का नहीं आता. Now we'll go to the next topic, that is this is over. I'm going for data memory. Now, what is data memory? Again, this is an IC. It consists of number of registers. Every register is of 8 bit. So, if I show it, I can show like this. So, basically, a data memory is again number of registers, and those number of registers are stacked together 1, 2, 3, 4 in that way, and every register is of 8 bit. Fine. So I have shown it 8 bit. The only thing is that the program memory was ROM memory, EPROM memory, and this memory is random access memory. The use of this memory is to store a data for temporary purpose. Now this will not store any program. Now this will not store any program. Program is there in the program memory. This will store merely a data. 10, 20 numbers, characters, ASCII codes, this one. So just it has to store the data. So this must be random access memory. Of course, to communicate with this memory, what we require? We require address bus, we require data bus. Address bus to define the address to which the controller wants to communicate at that time. So address of this register, every register must be unique. And so for the last one. So the addresses are given by a bunch of line. The bunch of line is called as address bus. So let me show it here. So it is again attached with the address lines. So this is known as address bus. Now to carry some data from memory to process controller back to this one, we require a bunch of lines. It's called as data bus. So it consists of a bidirectional data bus. So this is known as data bus. Of course, the control bus is not shown in the program memory. It is not shown in the data memory because control bus is not actually the bus. It is a signal. One signal to read the content, one signal to write the content. Content suppose controller to memory असे flow झाले, it is called as write signal, write process, and contents are moving, data is moving from memory to controller, that is called as read signal or read process. So that two lines are there. I haven't shown it time being. So when I understand how many lines are present in address memory, address bus, and how many lines are present in a data bus. Number of address lines are depends upon number of locations which are present here. And for that we have equation. 1, 2, 3, 4. Number of locations, number of registers are equal to 2 raised to 2 raised to n. N is sorry, 2 raised to n. Location should be equal to yeah, yes, it is blurred. Wait. Is it clear now? The screen is clear now?
Yes, sir.
Yes. So number of registers or locations is given by equation 2 raised to n, and n is what? Number of address lines. See. So 2 raised to n is equal to number of locations or number of registers which are present. Now these consist of 4096 different registers. So 2 raised to n is equal to 4096, and each one of them is 8 bit 8 bit. So I can write over here approximately it is 4 kilo 4096 exactly, approximately 4 kilo, and each one of them is 8. So this is named as 4 kilobyte or 4K into 8 memory. So if this much of locations are there, every location must have unique address to be assigned. So number of address lines equal to n is equal to 12. You can fill up this equation in a calcium, you can get the value of n. N comes out to be 12. One line, two addresses, two line, four addresses, three line, eight addresses, six lines, sorry, four lines, 16 addresses, five lines, 32 addresses, six lines, 64 addresses. In that way, 12 lines addresses are equal to 4096. So the address lines are 12. So obviously, the first line is named as A0 and the last line is named as A11 because this is a 12-bit address bus.
Sir, mic is off.
Okay. So this is a 12-bit address bus or 12-line address bus. The first line is A0, the last line is A11. सगळ्या लाईन्स शून्य असतील ऍड्रेस नंबर फर्स्ट, सगळ्या लाईन शून्य, शेवटची लाईन 1, ऍड्रेस नंबर 2. All lines are 1 means we have last address. The contents are not to be seen right now. Addresses are given by. Now similarly, this has a data bus. The data bus for program memory was of 16-bit. The data bus for program memory was of 16-bit, but perhaps here the data bus is of 8-bit. So at one time we can transfer 8-bit from controller to memory or memory to controller. So this is 8-bit. खरं ते 8 line म्हटलं पाहिजे, but in a controller or processor we used to count in terms of bits. So it's called as 8-bit data bus. असं असेल तर याची फर्स्ट लाईन, पहिली लाईन अशी असते, दॅट इज डेटा लाईन 0, D0, D1, D2, D3, D4, D5. Likewise, the last line is P7. So we are coming to the last. I mean, some more points are there. We will discuss in the next lecture. In a brief, the PIC18 microcontroller, which is known as a peripheral interfacing controller, has two memories. One of them is program memory, other one is data memory. Program memory is of 2 megabyte and data memory is of 4 kilobyte. The address bus for program memory is 21 bit. The data bus for program memory is 16 bit. Similarly, a data memory is consist of 4,000 locations. So data memory is of 4 kilobyte. Depends on this 4 kilobyte, the address bus is 12 bit and data bus is 8 bit. So up till this we have seen, we are going to put some more points in this data memory. Regarding program memory, we have covered everything, but data memory is bit complex. So some more points are to be expressed, but not now, maybe in the next lecture. Don't leave. First of all, let me take the attendance. Meanwhile, if you have any difficulty or doubt, please ask me. Just a minute. Okay, I have taken that this one attendance.